What I mean is that whenever a body is moving under gravity, there are three different velocities that are involved. One is the vertical component, two is the horizontal component, and V, the last one, is either resultant velocity or the tangential velocity. Welcome to VINDAL'S Academy. In today's class, I want us to talk about the secret or the principle of motion under gravity. But I want to beg you or plead with you for you to be in that level of an expertise level. Stop using this formula, V equal to U plus or minus GT. Because this formula does not give you the depth of knowledge for a body under gravity. For a body under gravity which is moving in this way, or which is moving up and down, then we now say that the body is moving in space. And when a body is moving in space, something has to be there. This vector, which is a velocity, has two dimensions, which is going to be, let's say the body moves in this direction, in this format. At every point on space for the body, there is what we call a vertical component of the body, and there is what is called a horizontal component of the body, and there is a tangential velocity V, which I'm going to call the resultant velocity, with which the body is using to make such a path. Now, if you are only using V, then you have limited the dimensions of this body, and your understanding and analysis to solving a problem on this is going to be limited. And if you have been getting the answer on this, that means you have been getting the answer under trial and error. Don't misunderstand me. What I mean is that whenever a body is moving under gravity, there are three different velocities that are involved. One is the vertical component, two is the horizontal component, and V, the last one, is either resultant velocity or the tangential velocity. Because for a body moving under a curve, there is a force pulling it towards the center, which is called centripetal force. But that's not the main concern of this video. However, using this one, which of these velocities are you talking about? And that is why when a body is thrown vertically upward, see what happens. People say that at maximum height, V is 0. And this is not correct. This is not true. Because at the maximum height, let's assume this place is the maximum height. For this body, this is the maximum height. V is truly 0, but which velocity is 0? Is it Vy that is 0? Is it Vx that is 0? That is V sub y, V sub s, or just V that is 0? Because at that point, we have a velocity, which is V sub x, and which is not 0. And we also have another V, which is also not 0. No, it can't be in this direction, sorry. So at this point, this is going to be equal to V. But this V is 0. What V is that? It is only the vertical component of the velocity that is 0 at that point. Because at that maximum height, the body is no longer moving up. The body has started moving down. So V sub y, which is the vertical component of the speed, is 0. Because if I consider this place, which is point A, to be the initial speed, then this is going to be the final speed. So this is going to be U sub y, which is the first initial speed, and this is V sub y, which is the final speed. Therefore, for a body moving from here to here, what is going to be happening? The velocity at A is going to be maximum, and the V, this Uy, is going to start reducing in value. When it gets to maximum height, it becomes 0, and then starts increasing again until before, not at this, not when it touches the ground, but just before it touches the ground, a very small time. That is the concept of this body. So for a body thrown up vertically upward, the right formula to use is not this, rather it's going to be V sub y, which is going to be equal to U sub y minus GT. This is the right formula to use, because this formula has expressed that the body is thrown vertically up. It is in a vertical dimension, not in the horizontal dimension. However, if I want to consider the horizontal dimension, the horizontal velocity, I'm going to use V sub x. which is going to be equal to, if there is anything like u sub x minus gt. Now, in this case, this is wrong as well. Why? Because g does not act on the horizontal dimension. So everything here is going to be 0. So this v sub x is going to be the same thing as u sub x. This is the condition which shows that the horizontal component of the speed does not change. It remains the same from this point, which is u sub x, v sub x, v sub x, and even to this point where we have v sub x. The value is the same thing. Why is it the same thing? Because acceleration due to gravity, g, does not act on the horizontal dimension. It only acts on the vertical. That is why this is correct, but this is wrong. And this is correct. However, one more thing I want to talk about is when a body is thrown up vertically up, or when a body is thrown and moving under a gravity, there is something we always consider, which is called the horizontal distance. Sometimes, if it is a projectile motion, we talk about range. However, the horizontal distance covered by the body, maybe the body was thrown up from here. How long, how far has it traveled before hitting the ground? So we say from point A to this level. So we are going to say horizontal distance, which is either a distance covered or range. In that case, I'm going to say that that distance s is equal to v sub x times what? T. Why do I use capital T? I'm going to use the total time. The total time is the time taken to reach the maximum height plus the time taken to hit the projectile plane again. And that is my total T. However, if I want to find from point A to, let's call this place point B, I'm no longer going to use this capital T. I'm going to say S is equal to V sub X times small t. Because from here to here is half of from here to here. So this is the horizontal distance traveled by the body. This is the horizontal component of the speed, because horizontal distance must go with the horizontal component of the speed. Now, when you now write S is equal to V times T, you confuse my kind of person, because I do not know the dimension you are talking about. But if I want to consider the maximum height traveled, I'm also going to say H sub y, which is equal to U sub y times T minus or plus GT, that is half GT squared. So for me to know that maximum height must go with maximum, that is height must go with upward initial velocity of the body for a body thrown or launched in a horizontal component. In the next class, I'm going to bring questions to prove correctly the principle I have shown you. Don't stop learning. Don't forget to hit the subscribe button, like this video, and share. Have a nice time. My father said it's not